Hello, everyone, and welcome to Transforming Foundational Production and Analysis for Better Governance webinar, the third in our 2017 series of Modernizing National Government webinars, addressing how national governments are utilizing modern GIS technology to more effectively and efficiently meet the needs of their citizens. My name is Kathleen Ojo. I'm a marketing specialist here at Esri, and I will be your moderator today. This webinar is being recorded. We will send you an email afterward to point you towards the recording if you would like to view it again or share it with your colleagues. There will be 2 question and answer sessions during the webinar, followed by one at the end. You can type your questions into the question window and we will address them at the appropriate time. Before we get started, I'd like to introduce you to our speakers today. Mark Seigan is the National Government Industry Manager for Mapping and Statistics here at Esri. Mark has over 33 years of experience working in GIS and mapping, including management positions at Esri, Navtech, and Rand McNally. Mark is actively participating on the United Nations Committee of Experts on Global Geospatial Information Management, the UNGGIM, and the Board of Directors of the International Map Industry Association Americas. Bryan Piersall is a solution engineer on the National Government Mapping and Statistics team. Bryan has worked in the GIS industry since 2002 with specific focus on empowering customers with the capabilities of GIS. Prior to becoming a solutions engineer, his primary domain was developing hard copy finishing workflows for defense and intelligence customers with ArcGIS for desktop and Workflow Manager for ArcGIS. His work is now centered around meeting with national mapping organizations worldwide to discuss how Esri's mapping and charting solutions for civilian topographic, defense, maritime, and aviation can help them to effectively meet their country's production goals. Let's go ahead and get started. I will turn it over to Mark, who's going to review the agenda and jump into our topic for today.
Thanks, Kathleen. Many of us continue to experience budget and staff cuts. At the same time, our customers are expecting access to an increasing variety of information products that are timely and authoritative. With fewer resources, our staff are often challenged to keep up with this demand. This leaves us in danger of not delivering timely and accurate information when and how our customers need it. I believe managing and automating your production will enable you to cut your costs and deliver current authoritative information to your customers when and where they need it. I invite you to see how we're working with organizations similar to yours to produce their information faster and at a fraction of the cost. We'll do this by first helping you visualize how you can be more efficient and how you manage your production resources. Next, we'll show you models for automating the production of your information products and share 2 case studies from government agencies doing this. Then we'll use the automated authoritative data to enable users to create their own products on demand. In our presentation, I'm going to play the role of an operations manager at a national government agency, and Bryan will be one of our production managers. As the operations manager, I ensure we deliver on our mission to collect, manage, produce, and share our authoritative information products, which includes data, maps, and web services. With ArcGIS, we use the same platform to manage all of the collection, production, and sharing of our information products. In our first webinar in the Modernizing National Government web series in March, we showed this. In our second webinar in May, we covered data collection and fusion with imagery. In this webinar, we'll focus on production and analysis. As Kathleen said, you'll be getting an email on how to view these videos, and you'll be able to see the other 2 in the series if you haven't already. Our government agencies are faced with a number of challenges, but the most common is funding constraints. This requires us to do more with less. It means we need to find ways to be more efficient, including improving our production management to identify and streamline ineffective processes, automating workflows and reducing repetitive tasks that cost us time and money, and modernizing our production systems to be responsive to increased customer demands, delivering our authoritative content to our customers when and where they need it. We're going to share with you how our organization can do more with less using ArcGIS, specifically how we can be more effective in our production management, realize efficiencies in automating production of our many information products from one source, and better serving our customers by offering them authoritative content 24/7 on their device of choice, so they can make better decisions on issues of national priority. First, let's look at effective production management. I'd like to pose some questions for you to consider. This is just rhetorical questions for you to think about. In your current production management system, how do you effectively visualize all of your production in one place? Can you click and see actual production data on your visualization? Can you see each project and status geographically on a map? Can you analyze job status and assignments to make load balancing decisions? Can you analyze which projects or staff need additional resources for better efficiencies? To answer these questions, I rely on our production managers to effectively manage and automate our production workflows. They can also adjust resources to respond to new customer requests for updated information and information products to address national issues such as the disasters, similar to what we've been having recently, or public events. In a minute, Bryan will show you how our workflows are standardized for repeatable processes, ensuring consistent quality information products, how our production managers can analyze our workload and optimize production resources to gain efficiencies, and how this gives us the agility to quickly adjust to meet our customers' needs. One of our production managers, Bryan Piersall, will show you. Bryan?
Thanks, Mark. So standard repeatable processes and not only knowing what staff is working on, but where staff is working on tasks can be the foundation for a streamlined approach for effective production management. This is a sample application that comes bundled with defense mapping for server, but can be configured for any production mapping industry. The solutions within mapping and charting contain specific tools, data models, and templates that allow you to increase the efficiency of your GIS production system. Using mapping and charting allows you to streamline your organization's data management, which fosters rapid data collection, production, and shareability. Production Manager is a thin client application that allows both managers and users to see what work is being worked on at any given time, but also to see where that work is taking place. In this case, we have two separate business units within our organization. One that focuses on civilian topographic mapping as indicated by the blue polygons, and another that is focused on a defense product, which is represented by the red polygons. This, of course, can be configured to support any mapping business unit within our entire organization, such as aviation charting, defense mapping, civilian topographic mapping, and even maritime charting, just as a few examples. In addition to seeing what work is being done and where, Production Manager allows you to examine the status of your production system as a whole or as individual job component parts. This is important because it allows you to examine the production line at either a macro or a micro scale. By interacting with the queries, I'm able to examine the status of production for that business unit. I can see what the schedule of status is for the work across this business unit and seeing whether the work is on time or behind schedule. And I can make adjustments to the workload from this application, which I'll demonstrate shortly. I mentioned previously that we can examine the production status at a macro or a micro scale. And by looking at the status of production at the business unit level, I can get an idea of how things are going. But what if I wanted more information? Well, I can click on any of these jobs within the system to obtain job-specific metrics and status at a micro level of granularity. I can also task work based on a number of different criteria, such as job type, a job assignment, whether that be assigned, unassigned, assigned to a group, or assigned to a specific user. I can select a start and due date, and I can also give the job a priority. All of this is based around an area of interest, or AOI, which is the geographic extent of a job. And the purpose of the AOI is to highlight an area where the majority of the work is going to be performed, but it's also going to help enhance job history reporting and speed user orientation. When I create this job, it will be assigned to that staff, and that staff will automatically be notified by email by the system that they have new work in their queue. Here I can see distribution of work across my system. This one particular staff member has 14 jobs, whereas this other staff member only has 3. By interacting with the graphs, I can see who has which jobs and where they're spatially located. But I can use Production Manager to load balance this analyst's work to another staff member. So traditionally, work is assigned from a manager to an analyst. But what then? There's no traceability and there's no reporting. And there's no practical way for the analyst to document what they did and when. And there's really no real way for the manager to have constant updates on the status of work. The great thing about Production Manager is that every time a user interacts with a job, it is date, user, and time-stamped. So the thing here is running accountability and ownership of each task. Prior to implementing Production Manager, the traceability and reporting roadblocks cost money and they cost time. And if we multiply this times multiple analysts and multiple jobs, or many analysts each having many jobs, we can quickly see that simply managing these resources is a job all on its own. And Production Manager is the solution for streamlining this whole process. It provides transparent job status to anyone with access to the application, and managers can not only use it to task analysts, but they can also use it to check on the status of any job within the system. There's reporting capability at the system level and at the job level. And we can even set it up so that email alerts are triggered when certain events take place within the job's life cycle. The appropriate staff can be notified. Most importantly, though, it provides a single source for repeatable workflows. Production Manager integrates the entire Esri software platform and relies on both desktop and enterprise, along with Data Reviewer for server and Workflow Manager for server. And it's all completely configurable based on your organization's needs, industry, and requirements. And so now that we've used Production Manager to make some changes to better load balance the production schedule, my operations manager will have been automatically notified that I've made those changes, and he can see those changes reflected immediately in his dashboard. Mark?
Thank you, Brian. So now we're going to take a minute here and take some questions from you out there that have been watching this. So we invite you to type your questions into the questions window. Give anyone a chance to type in those questions. All right, well, one question we have is how is the information in the charts on the dashboard updated? So Brian, I think that's to your demonstration, if you want to answer that.
Sure. So the metrics in the graphs are calculated as a function relative to the start and the end dates that the analyst has within the workflow. And it's also correlated to the step that the analyst is on within the workflow itself. Each step within the workflow is assigned a percentage complete, and these graphs take into account that percent complete relative to the time remaining on the job to calculate those schedule status.
All right, we've got one more question here. I'm wondering if there's another application of this product. Also, is there something like that coming to ArcGIS Online?
Well, right now there is nothing else like this product from an Esri standpoint. from a platform standpoint. And in order to push something like this to ArcGIS Online would require a bit more engineering. So I would say no to that. However, this is a web application, so it can be consumed on any device, anywhere, at any time.
Okay, thank you, Bryan, and thank you for those questions. We're going to move to an opportunity to get some feedback from you. We're going to move to a poll question, and the question that we'd like you to answer, and you can just go online and click there, is how do you currently get a status of production in your organization? So you can put down that we use spreadsheets, or we use project management software, we have our own application, or we don't need to status production in my work group. So I'll give you a minute to just kind of click on one of those. We've got almost half of you responded, over half of you now. So I'll give you a couple more seconds just to make a selection there. All right, looks like it's topped off there at about 70% response. All right, we're going to close the poll, and it looks kind of split here. About a third of you are using spreadsheets, and about a third of you don't have a need to status your production. About a quarter of you use some sort of project management software. So thanks for the feedback on that poll. Hopefully that was kind of an interest to you, each of you. We'll be doing that again at the end of our next section, and we're going to move to taking a look at automation of production and the efficiencies that we gain. We've looked at automation within our organization to help us address our need to reduce the number of staff hours required to make all of our different information products. This includes ones of different scales, content, and purposes. Automation enables us to maintain data once and reuse it across all of the information products whenever we need it. It improves the quality of our data by having consistent processes for our production generation. Automated workflows and processes allow us to maintain our authoritative data store that we can then produce many different information products from for different scales and different types of maps. In this example from the Dutch Cadastre, you can see they use their 1 to 10,000 scale top 10 NL data to generate 1 to 10,000 scale, 1 to 25,000, 1 to 50,000, and 1 to 100,000 scale digital maps, as well as web services and maps for apps. In addition to generating those civilian information products, they also produce a few defense information products from the same data with a different map specification and symbology. In the words of Ben Bruns, the manager for topographic mapping at Dutch Cadastre, he said, national mapping organizations worldwide share the same objectives: make better maps, cut costs, and improve customer satisfaction. The Dutch Cadastre succeeded by transforming the production of geoinformation with the development of automated generalization. Today, we produce maps 5,000 times faster at 25% of the production costs, and our customers are very satisfied. So how did they realize these outstanding efficiencies? On the left, we see an example of the original 1 to 50,000 scale topographic map, which took 28 cartographers 5 years to map the entire country of the Netherlands. On the right is the new map, which after updating their 1 to 10,000 scale database, they can produce all of the 1 to 50,000 scale maps of the Netherlands in 3 weeks using an 100% automated process. This is how they produce maps 5,000 times faster at 25% of the production costs. The next slides are from a presentation I did earlier this year with Lorraine McNerney, the general manager at Ordnance Survey Ireland, where she described how they are modernizing the Irish National Mapping Agency. First, they start with their authoritative data, Prime 2. This is a single source of truth that is scale independent. It has over 50 million features represented in a real-world data model. They then automated the production of their information products using what they call their multi-resolution data store. Their multi-resolution data store uses their Prime2 single source of truth data and automatically generalizes the data for large-scale, regional, and national information products from the equivalent of 1 to 1,000 up to a million scale. This enables them to automatically produce their information products at different scales and with a wide variety of different types of maps, map data, and web services. Here's an example of their digital map data automatically generated at 1 to 50,000 scale. That same data was used here in this example of a 1 to 50,000 scale hard copy print map from Ordnance Survey Ireland's Discovery Map series. Here we have a high-level overview of how the automation is done using authoritative content and automated geoprocessing models to generalize the features and generate the final cartographic information product. And this is a detailed view of one of the models, with the green ovals being data and the yellow boxes that run geoprocessing tools to automatically run this model. Now Brian's going to show you a little of how this automation is done. Brian?
Thank you, Mark. Okay, so first we want to show you what's possible out of the box in both pre and post automation using our swipe tool. This is a quick application that I put together that shows the original 1 to 25,000 data on the left and the post generalized data at 1 to 50,000 on the right. And by using the swipe tool, we can immediately see differences in these two data sets. Roads become less detailed and more angular, and certain buildings not only change their geometry, but also their location in some circumstances. And in other instances, certain buildings that don't meet the area threshold of the generalization model are eliminated altogether in the new generalized data set. So how did we get from a large scale data set to a smaller scale data set via automation? Using the Esri civilian topographic map data model, which is available in GitHub, there are generalization models that have been created in Model Builder, and they look like this example here on screen. As Mark mentioned, the blue is essentially our input data. The yellow boxes are geoprocessing functions that occur geoprocessing tools. And the green is the output of that geoprocessing that can be iterated and used with other geoprocessing tools. So in this example, we have an input data set with a series of selections and geoprocessing functions that occur prior to the data being written into the generalized feature class. So basically the data comes in, it gets geoprocessed several times over. The building conflicts get resolved in this example, and then that is ultimately written as a separate generalized feature data set. Now, depending on the model that's being considered, they all have different levels of complexity. As we can see here on the right, there are a number of different models that come bundled with the CTM generalization package. These have to be run in order. They can all be run independently if we so chose, but we do provide a script that allows these to be run in batch, which will not only save time, but it allows further automation. And so I can say what my input workspace is at the geodatabase level, choose that AOI or area of interest, select my output folder, give it a database name, and run the tool. So this allows us to run these models in sequence. So finally, I just want to show you again some of the pre and the post generalization output using these tools and the data that comes packaged in the civilian topographic map data model within GitHub. So Mark, that's just a really quick overview of just one example of how we do automated generalization.
All right, thank you, Brian. So we're going to pause again and take time for questions. So you can use the question window there to type in any of your questions on what Bryan was just showing on automation. All right, we've got a question here. Can you modify the results of your automation processes, and if so, how? Well, I'll start with that. Any of the parameters in the tools can be modified at any time, and then the generalization models can be run repeatedly. So in fact, this is the process that's used to refine the models and continually improve the models, and then they can just continually be run. And you can modify them at any time to improve them. Bryan, do you want to add anything to that?
That's exactly right, Mark. And I think you hit it square on the head. And a good example of that would be if for your own particular need, if you wanted to have a building area persist into a smaller scale, that comes as part of the template within CTM. If you wanted to change that area threshold, you can modify that within the model, save it, and then rerun it at will.
Okay, thanks, Bryan.
Mm-hmm.
All right, we've got time for more questions. We've got another question here. Have the methods used in the algorithms been validated in peer review journals? So I can take a first stab at that. A lot of the thought processes that went into the algorithms have gone through a number of academic rigor, particularly with Barbara Buttonfield at the University of Colorado, but particularly Dr. Cindy Brewer at the University of Pennsylvania. They went through and worked through this kind of multi-resolution automation and generalization of the data. We've since taken some of their original work and written them into the algorithms. They've been refined by a number of organizations. Each time an organization picks this up, they modify it and enhance it to their needs. The Dutch cadastre is a good example of that. They were working also with Dr. Jantien Stoder at the University of Delft, as well as others at ITC and Enschede that continue to look at and how they can refine and enhance these models. A number of these things have been shared at the International Cartographic Association on the work group on automated generalization. And some of these have been written up in the International Cartographic journals. So hopefully that answers that question. Bryan, is there anything you want to add to that?
No, Mark.
All right. We have time for another question. Do we have any other questions out there? All right. Does not look like we've got any other questions. So we are going to move to our poll questions then. So we'll give you a chance, give us some feedback again. So this is our second poll question. So automating the production of our mapping products at different scales from one database let me say that again. Automating the production of our mapping products from different scales from one database could save us, and is it 50% or more of your staff time? Is it 25 to 49% of your staff time? Is it less than 25% of your staff time? Or is it that this is not really applicable to your work group? So we've got responses coming in. We're almost at 50% here now on responses. So we'll give you a few more seconds to respond. Oh, there we go. Got quite a bit more. We're up to about 2/3 of you have responded. I'll give you another second there. All right, we're going to close the poll now. And it looks like for quite a few of you, about 40%, this is not applicable to your work group. But there's another 22% where you said you could probably save 50% or more of your staff time using automation. And then another 22% said that less than 25% of our staff time. So thanks for the feedback on that. We'd be happy to continue that conversation with any of you that are interested, that think it would be useful for you. And you can contact us or just indicate your interest in contacting if you want more information, because we're going to move on to our third section here. So users want access to current information quickly and easily on the device of their choice. We can provide them with the ability to generate product on demand. Esri enables our users to create standardized map products on demand, anywhere, anytime, and on any device from your most up-to-date authoritative data. For example, in the recent hurricane in Florida that Bryan just experienced, there are many changes that can be reflected immediately in the authoritative data. Anyone with access can then use this app to create information products on demand. Users can do this by simply accessing the Product on Demand app from any device, defining their area of interest, their AOI, an information product that they need from the authoritative data that you just saw Bryan updating using automation. And the user gets a standard looking map through the web app with up-to-date information and data. So Bryan will show you how your authoritative content can be produced at any time by your customers through a Product on Demand app. Bryan?
Thank you, Mark. So this is Product on Demand, or POD, which is another sample application that's bundled with production mapping for server. And the authoritative information products from the automated production that I just showed can now be used as the base data to create a product on demand, which is near to specification. There are a number of tools that I can use in this application to generate products, such as fixed 1 to 25,000 scale or a fixed scale, which will create a new version of an existing map sheet. I can create custom center points. I can run linear events, linear map books, and so on. But for this example, I'll just go ahead and create a custom center point, which will generate one new map sheet that will span, in this case, 4 existing map sheets. I can even move this around if I wanted to, if I wasn't satisfied with the placement of that. Now for the export format, I can choose a number of different image type formats or even a map package, which would consist of a geodatabase and associated MXD that's ready to go. But for this example, I'll choose a PDF. It's in my export queue, and I can get a thumbnail of what it's actually going to look like even before it's run off the server. I can give it a custom title and export the product. Now this product takes less than a minute to export, but to show you what it looks like, I have one that I ran off this morning that I can show you. The output of Product on Demand is a nearly finished map product that's fit for use, and it includes all standard symbology based on my organization's standards, grids and graticules, legends, and all surrounding marginalia that's specific to this map sheet. In our next webinar, we'll show Product on Demand in more detail. But just to show you how fast this really happened, let's check on the status of that map product that I started to export. Here, all I have to do to get this off of the server is click the hyperlink, and I can download it from the server and share it at will. And just to show you that this is not smoke and mirrors, you can see when I scroll down to the bottom here, you can see my custom title that I pasted in there. But also down at the bottom, I have a date and timestamp that shows a time of right now, Pacific time. So this application is both fast and powerful. And like Production Manager, it can be completely configured to your organizational needs. At this point, we just wanted to show you how we could use an application such as this to create products that we can share at will. Mark?
Thanks, Brian. So product on demand is one of a number of ways to automate the production of information products and to share them. Once our production groups have finished their information products, they can share them immediately within our organization or outside to all of our customers, as you just saw Brian do. This is the authoritative information that's used to support better decision-making on issues of national priority. By applying our foundation information to issues of economic development, national security, or social or environmental challenges, we're contributing to our nation addressing these issues. This information can be shared to our customers in a number of ways using WebGIS. This is the subject of our next webinar in the Applying GIS to Issues of National Importance, and it will be our final webinar in our series on modernizing national government. Before I move to our question and answer period, I'll just give you the option, the ability to see how you can attend that. You can see you can go to this web link here to register for the next webinar in our series, Applying GIS to Issues of National Importance, and it'll take place on November 29th, and you can register for that now. So we're going to get to our final question and answer period. Think about your questions here in a moment. So what we demonstrated for you was how you can analyze and optimize your production management so that you can be more effective. We showed you how to implement automation to realize efficiencies in your production, and enabling product on demand for your customers to access your authoritative information 24/7 on any device. So with that, we'd like to give you, we'd like to open it up to questions, give you the opportunity to ask any questions you might have. Just type them into the question window there. We'll take those. So here's a question for the Production Manager app, and that's the first one we showed. Is that available? To, or how is that available? So
okay.
It can be. Yeah, go ahead, Brian.
I was going to say it's available in a couple of different ways, and I'll just address the security of it first. So it's a web app that's hosted on one of our servers for this example. When it's deployed, it's naturally hosted within your architected or your architecture, your enterprise. The security of that is tied to Workflow Manager. That's really what's driving that behind the scenes. So as long as you are a user within the Workflow Manager database and participate within groups within the Workflow Manager database itself, you can have access to that application. But it's available through the web, and as long as you've got that user authentication, that's how you're able to access an application such as that.
Okay, so it can be available to anyone as a organization sets that product on demand or that the Production Manager app up. It's available to anyone in the organization that you give permission to, so it's all permission based. And you can make it available across work groups or to other people across your organization. It's really managed by you as the user. And you can have many different views. So there can be a view for the production manager, there can be one for the production operator, there can be one for the executive to get a high level. So it really is configurable for what you want to do. Let's see, if you have any other questions, please just type them into the window. We've got another question here. In the production automation you showed, how do you build the automation models? So you can do it in a couple ways. You can use Esri's model builder, which is in ArcGIS, or you can use Python to create the models. In the case of Dutch Cadastre, they built the models in Esri's model builder, but then they added Python scripts. Other organizations like Ordnance Survey Ireland kind of used both, but they use a lot of Python scripts. So you build the models by specifying which data to use. So you identify your source authoritative data. You identify which geoprocessing tools to run and in what sequence. And then in that way, you build the models. Bryan, you want to add anything to that?
Just something, just to sort of build upon what you were saying. Even though the models are built within Model Builder, you can run them from Python. You can export them out as a Python script and run them from there. So it does allow sort of that cross functionality, and that's what's basically what allows the models to be scriptable.
Okay. All right. Great. Thanks, Bryan. Any other questions out there from our audience? You want any more details on the automation? It's pretty amazing the results that you can get, the amount of time savings by automating your processes. All right, I'm not seeing any other questions here. We'll give you a little bit of more time here to ask any questions. All right. Well, not getting any more questions here, so we just had those two. So we'll move on here. So Kathleen, you want to wrap it up and give us the final information?
Absolutely. Thank you all for attending today. Do not forget to register for the next webinar in our series, which is coming up in November, applying GIS to issues of national importance. And I'm going to chat out the link right now, so you'll be able to click that and register. This webinar has been recorded. We will send you an email as soon as the recording is ready to view, and we hope that you will share it with your colleagues. I will also send out a follow-up email immediately after this, and feel free to respond to that with any additional questions that you might have for our presenters. Also, please don't forget to take the survey that will launch as soon as you exit the webinar. We really appreciate your feedback. Thanks again, everybody, for coming.